So I'm Mr. Scott, and I'm going to be partnering with Mr. Hamashak on this presentation. And
Hello.
we're going to be going over different central tendencies today.
Excuse me. What is a central tendency?
Well, central tendency is simply a single value that attempts to describe a set of data by identifying the central positions within the set of data. And as you'll find out later, the central tendency can kind of be different depending on what you're looking for.
Okay, so are those three parts what you have here listed below? The mean, the median, and the mode?
Yes, those are the three parts of the central tendency that I will be covering is the mean, median, and the mode.
Okay. Well, let's go ahead. Would you mind explaining those? Kind of
All
what
right.
they are?
All right. Well, the mean is simply the average of all the data. So let's say we have like 7 different numbers. If we use 7 different numbers, we will add those numbers up and then we'll divide by 7 and then we'll find the average, which will be most of the time will be pretty close to the middle of the set of the
Okay.
data. And then the median, this is the middle number of all the data, which if you have 7 numbers, you will only use those numbers and you will go from left
Mm-hmm.
all the way to the middle, and then you go from right to the middle until you kind of meet up, and then that'll be your middle number. And you'll learn more about this later. It'll make more sense then. And then the mode
Okay.
is the number that appears most frequent in your set of data, which that'll be the number that shows up most of the time.
Mm-hmm. Okay. So thank you for that explanation, by the way. Um, how would you? Now, this is all interesting stuff, but
Uh,
how is it useful? How can it be practically applied in real life?
well, in the mean would be for me, and a great example that I love to use is sports always. I always go back to sports. And I would
Mhm.
use kind of like basketball, NBA, they have an 82 game season. And once that they do is free throw attempts for per game, which is for every game, which is simply an average or the mean number of free throws per game. So over a year you have 82 games. They will shoot anywhere from 0 up to a lot of the time, the most would probably be about 14 free throws a game. I mean, that didn't sound a lot, but in the NBA, it is a lot. 14 free throws is definitely a lot. So you have 0 to 14, and the number will vary depending on the game, however many you shoot. So you have a number in between there for 82 games. So however many free throws you shoot, they will write that down for that game. And then you'll have 82 different numbers up there. So then what we'll do, we'll add all those numbers together and then we'll divide it by 82 and that'll give you the average. So at the end of the season, you will be estimated for like the next season. They'll be like, hey, this person's going to shoot probably like 6.5 free throws per game, but they'll shoot 7.4 free throws per game. And it's just
Mhm.
kind of like an average. And the median, which you won't really see this that much, like people looking for this, it's at the 50th percentile. It'll give you just like in the middle of your data. It'll be like, hey, I have all these numbers, but if I just want to kind of like shoot right at the middle, let's say I have like 70 to 100. I just want to shoot right at the middle. It'll be about 85. And you can do this with like percentages or whatnot in the class and be like, hey, the middle of my class, like right in the middle where people should be at, it'll probably be like
Mhm.
85%. And then the mode is the number that appears most frequently. And this one I would use kind of like when I'm going to buy something or whatnot. Like let's say I go to the store and what
Mhm.
I want a certain color. Or like I want to be popular like everyone else. What item is the most popular item? Obviously, obviously it's going to be the item that's sold most.
Mhm.
So it'll be the
True.
number that's the highest of that item that's sold most, and that'll be the mode. That's what they'll keep track of, and that'll show them what's sold most, and that'll show you, man, I should buy that because everyone likes it, obviously.
Mhm. All right. So while I'm thinking about it, could you kind of clear up the difference between the mean and the median, or kind of
Oh,
make a
definitely,
distinction?
definitely, I can. So the mean is right here, and as you can see on the left, I have the sum of all the data values over the number of data values, and right here, I just put these 7 different numbers up for you, these numbers, and I've
Mhm.
already gone through and figured out the mean, but follow along with me, please.
Mhm.
So right here, I have 500, 1,000, 50, 11,000, 950, 50, and 450. Now, if you add all these numbers up, as you can see right here, you add them all up, it'll give you a total of 14,000. Now, please do go add this up yourself just to make sure I have everything correct. So since we have 7 numbers and we have the sum equaling 14,000, 14,000 will go for the sum of all the numbers right here on the top. And then we will put that over the number of data values. Since we have 7 data values, we'll put that over 7. So 14,000 divided by 7 equals 2,000. So 2,000 will be our mean, sometimes known as the arithmetic average. And yeah, it's a tough word to say. It's really a mouthful. And the median, I'm going to use the same numbers right here. So the median, as I was talking about, if you would go from left to the middle and then from the right to the middle, what I did, I showed you how I would do it. You put out your 7 numbers in order, in numeric order. So I did 50, 50, 450, and so on. And as you can see, I started on the left and on the right at the same time. I kind of just started right here with 50. I put a 1 right here. And then I came over here to 11,000. I put a 1 right there. And then as you can see, boom, I got right to the middle. We're at 50, 500. 500 is my middle number. It's right in the middle, and it's number 4. So my median of this set of data will be 500. And a little side note that with even amount of numbers, you will have 2 middle numbers. So let's say if I were to get rid of this one, you have 2 middle numbers, which will be probably in the middle of here or so. And then what I would do in that case, I would add the 450 and the 500 together, divide it by 2, and get right in the middle there, which will be 475. But if you have an odd number, you will notice you'll have a set median.
Okay, so is that kind of what would happen if you added an additional number to your set of data here?
Definitely, definitely. That's a good thing to point out. If I were to add one, you can either add or take away. But if I were to add one to the median, I would simply just kind of put it over here. I can drag one over here, or like I did before, I just take one away, boom. And then my median would drop right here. But if I were to add a number, let's say I add like 12,000 or something like that, I'll add 12,000, put it at the end over here. And then my median would jump in between 500 and 950. Now, if you were to add these two up and then divide it by 2, you would have a median of 725. That would be a new median instead of 500, because you have 500 and 950 as your 2 medians, and then you would have to divide them by 2. Now, if you were to go back to the mean and you would add a number, I didn't do this calculation, but it would change it for sure, because it doesn't matter if you add a lower number or a higher number. If you add a lower number, the median would essentially go down. But if you add a higher number above the highest or above the average or the mean, then the number would be higher, just because it would be more than 14,000, and then we'd also divide by 8.
Okay, good job explaining. So one more thing for you. We've talked about the median and the mean plenty, but how would you explain the mode?
Well, with what I figured out on the mode is simply, honestly, for me, I use mostly just common sense, because this is something that you're able to see. And this one is good to know that it's not always affected by the addition of another number, because you can just add a number. Now, unless you add a number that's the same as one that's already in the data, then it can be affected. But generally, it's not affected by adding another number, whether it's larger or smaller. And this is the number that you will see the most, the number that outweighs the others by how many times that it appears. It's mostly easy to see on a graph, but I did it right here. I put my numbers in order. You are using the same data set. We're using 500, 1,050, 11,000, 950, 50, and 450. If I put them in order, you can see that 50 is the only one that repeats. So, easy common sense. The mode is the one that's going to show up the most. 50 obviously shows up the most. So we have 50 as our mean.
All right.
And that's kind of all that I really have for you guys today. But Mr. Hamashak, after I show you the work that I would like for you guys to go do, so that way you'll know how to do all this stuff, Mr. Hamashak will have something for you. But for right now, I have some things that I just want to go over with you to kind of clear up everything and to kind of expand your learning. So I gave you a link right here, and if you would, you can click on the link, follow it, and together we're going to work problems 1 and 3. And I've already done these ahead, and you can go onto the site and you'll see a bunch of different problems. So number 1, it says, to get out of debt, Ronaldo has a has made a goal of paying $500 per month on his credit card bill for 6 months. After 5 months, he has paid these amounts: 550, 400, 600, 525, and 450. How much would he have to pay in the 6 month to average $500 per month? Well, as you can see, he's already paid 5 different payments. All we have to do is add these up, and then if he wants to pay $500 per month for 6 months, if you do 500 times 6, it'll give you 3,000. So then we'll add all these numbers up for 5 months, see how much he's missing from the 3,000. So if we add all these numbers up, he'll have 2,525. So if you subtract that from 3,000, you'll have 475. So then in the 6 months, he just needs to pay $475. Now you're like, how does this relate to the lesson? Well, to check your answer, how about you go back, you're gonna add 475 to 2,525. That'll give you 3,000. And then this is like finding the mean or the average. You just do 3,000 divided by 6, because that's how many months there is, different numbers there are, 6. It'll give you 500, essentially $500 per month. Now on to number 3. Maria is paid by the week based on the number of hours she works. Her paycheck for the first 6 pay periods of the year are for the following amounts: 288, 320, 256, 280, 288, and 332. Now, based on the mean of the data, how much is she expected to earn for the year? Now, this just gives you a hint: 52 weeks in 1 year. 52 is an important number that we're going to want to remember. Now, just to find the mean of the first 6 pay periods, we're going to add however much she made up in the first 6 pay periods. So we add all that up, you get 1,764. Now you want to divide that by 6 because that's how many paychecks she's had. And then you get $294. That's how much she's averaging per week. That is also the mean. Now, just to finish the question out and figure out the answer, we're going to multiply that by 52 weeks. So since 294 is the average for 1 week, we're going to multiply that by 52, which gives us 15,288. She will earn for the year $15,288. Now, just to expand your knowledge and everything, in class or kind of just in your own time, I want you to work these. Go to that site, and you're on there. There's 6 pages. On page number 1, you're going to work number 2, and then 4 and 5. And on page 2, I want you to work 1 and 4. And on page 3, I want you to work 8 through 10. And then this will be due next time we meet, or you can email it to me. I want you to go to the same site. And then on page 4, I want you to work problems 14 through 18. That's not a lot. It's only 5, not many. And then for extra, however many people are in this class, I want you to find mean, median, and the mode of the ages of students. And then you're going to send that to me, show it to me 1 week from today, and I want to see all of your answers. And then now Mr. Hamashak is going to expand your knowledge even more on the different central tendencies.
All right. Well, thank you so much. Let me get my screen going. And now we're rolling. Can you see my screen?
Yes, sir, I can.
All right. So we'll be talking about tendencies along with the measures of variability. So let's waste no time. Let's get right into it. Got any questions?
How would you describe the concept of standard deviation?
Oh, that's a good one. Let's get right into it. Well, for me, I like to divide it up into 2 parts. First, let's talk about the arithmetic mean. You talked about this earlier. How do we calculate the mean of data?
We add all the numbers up, and then we get the total amount of that, and then we divide it by however many numbers there are.
Correct. And that's actually the basis for how you find the standard deviation of a set of data points. You start off with your arithmetic mean. So as we see here, each item adds up to 15. So despite having 3 different individual numbers, they come up to the same answer as if you added 5, one single number each time. And then you calculate, and then you take that mean, and you kind of calculate a common number to split things up by. As you can see here, the line in the middle of the small and large standard deviations have a solid bold line in the middle. that is the mean. And once you go to the left and to the right of each section, that is one standard deviation. Like from the square, from in the large deviation, one going from the bold line mean in the middle to the end of the red green line, it would be one deviation. Going to the green blue line would be two deviations. And then to the blue and white line is three deviations, and so on and so forth. So basically, you start with a mean, and then you use that as a basis to find out common lines of deviations that split the data up. Good question.
Okay. I see that you have something on your sheet about isn't a rule. It's looks like it's 68-95-99.7 rule. I'm not really understanding what that is. So can you help me out with that?
Absolutely. The rule he's talking about is the 68-95-99.7 rule is what it's formally called. And it basically means that number of points are split up, or typically the percentage of data points are within a set of deviations. Here, according to this rule, about 68.5% of your data points will be within one deviation. 95% will be within two deviations, and 99.7, or nearly all the data, should be within three deviations. This chart over here demonstrates that concept. Do you notice how, like in the pink bars have 34%?
Yes, I do.
That just means that if you go in either direction on the number line, you're still moving by a single deviation. So as a result, half of that deviation is going to be on the left of the median, and the other half will be to the right of the median.
Okay.
Do you get it?
Yes, I do.
All right. So.
And then how would you organize a set of data points to show the usefulness of a standard deviation?
Ooh, good thinking. For me, the best way to do it is to kind of show it off into a problem. So let's say you work at a computer lab, and you've got 10 sets of laptop computers with batteries that can last between anywhere from about 1 to 15 hours. And you want to calculate, try to see how long each computer lasts and see kind of how it lines up. So with that in mind, now I ran this through a generator, and your computers lasted 1, 9, 6, 7, 3, 8, 11, 13, 12, and 10 hours respectively, what you would do to calculate the standard deviation is, first of all, start off by accounting for the mean of the data, which mathematically I did do the math here a little earlier. The data should be 1 plus 9 is 10, plus 6 is 16, plus 7 is 23, plus 3 is 26, plus 8 is 34, 11 is 45, 13 is 58, 12 is 70, and 10 is 80. So that would be our sum, and then divide that by the number of data points, which is 10, and that would mean that your mean is 8. So, and we also have here for you a chart that actually shows the battery ranges of each of the 15 or the 10 laptops. I'm sorry. So as you can see, the best laptop number 8, can last for up to 13 hours, whereas laptop 1 is the weakest at only 1 hour. Now with that in mind, and with the mean being 8, we now, for our next step, find our variance by taking the distance between the data point and our mean of 8, and then squaring that distance. So in this case, 1 is 7 units away from 8, and then we square 7 to get 49. So I went ahead and did that for you for the rest of them, and our final addition problem comes out to 49 plus 1 is 50, plus 4 is 54, plus 1 is 55, plus 25 is 80, plus 9 is 89, plus 25 is 104, 16 is 120, and 4 is 124. So once you have that, you'll just then calculate the square root. Let me double check my math here. 49, 50, 54, 55, 80, 89, 99, 109, 114, 124, 130, 134 is the answer to this problem, not 124. I do apologize for the typo. So you would take this number and then divide it again by find that the mean of that data is 13.4. You would then take the square root of 13.4 to find that the standard deviation, the line of deviation, would be 3.7. It is 3.66, which is rounded up to the nearest tenth, which is 3.7. So if you wanted to take the mean of 8, going away 1 deviation would take you to 4.3 to the left and 11.7 to the right. You can use that data to see how the computers line up with the data and see which ones are weak and kind of which need to be replaced and which ones are running really strongly. Excellent question.
So how is the standard deviation related to the variability of the data points?
Ooh, that's an interesting one. It relates because we're trying to calculate the range of data. So you see how we have a mean here,
Yes.
and we're using that as a basis to try to kind of find the variability, the range of data, or the spread of data from that median point. We talked about this by going over X amount of standard deviations away from the mean that serves as our basis. There are other variability points. There are actually 4 of them. Another noteworthy one is the range, which is simply taking the highest extreme value from the lowest extreme value that's represented and finding the difference between the 2 points to show how far the data spreads out from one extreme to the other. So that's another form of variability that's different from the standard of deviation. All right.
Okay, so can you I'm curious if there's an alternate way of calculating the spread of data points.
Those are actually 2 different ways you can calculate the spread of data points. One by using the mean as a basis for your data, and by just looking at the extremes to find a range. Now there are 2 other ones there that make up the 4 ways of finding the range of data, the spread of data points. One is by looking at the interquartile range of data points. If you look to our chart here on the left, we have 10 data points, and we split it up into a lower and upper half. Now we take the median of these halves, and these represents our interquartile ranges. And from here, we see that the upper quartile range is 77, and the lower half is 64. Difference between them is 13, and that finding that interquartile range is the 3rd way to do it. And the final way to do it is just by looking at the variance, seeing how 2 different sets of data points that have the same mean can be represented very differently here on a chart. All right, I think we have time for one more question.
Okay, can you assess the value of measuring variability in data?
Of course. To me, the most important thing about variability in data is that it helps you explain or understand what that data is telling you. Like, if we just take raw numbers and stuff, and you didn't look at the context or see how all the different points to relate to each other, then your view of that data can be skewed and manipulated to fake news, and we don't want to spread any more lies. So basically, the most important thing I want y'all to understand for this is that understanding variability and different ways of calculating the way that the data works helps you gain a better understanding of what these numbers are telling you that you would not get if you just looked at the raw numbers. Very good, excellent questions. All of them were good. I think that's all the time we have tonight. So thank y'all so much. Have a wonderful night.